source NAT, okay, where we will see that how we can translate the IP or the port. Okay, since I am dealing with the source NAT, so that means we will only be translating source IP or the source port. Okay, nothing else. Maybe both, maybe any one of that. It depends. Now, see the first one, overload. Overload is also called as many to one. Okay, so overload is also called as many to one, and this is a default NAT. Okay, this is the default source NAT. So if you simply enable the NATing, you will find out that it is behaving as an overload. Now, what is this many to one? Let's take an example. Let's assume we have two PCs. Okay, multiple PCs you may have. Okay, you may have 100 PCs and all, but I'm just taking an example of two PCs connected to a switch, connected to the FortiGate firewall, then connected to the internet. Okay, so the public IP here is what? Let's say 1.2.3.4. Okay, the PC1 and PC2. PC1 IP is 192 and PC2 IP is 192.2. That means here IP is 192.3. Clear? Topology is clear. Any doubts into the setup what I've just drawn?
No, sir.
Fine. Now see this. Let's assume we have configured the source NAT here on the FortiGate firewall, and that is of the overload. Okay. So in the overload, you will get an option of external IP. That means the NATed IP. So there we defined that 1.2.3.4 is there. So we said that no matter how many sources are there, translate all these sources to this IP and then only send the traffic out. So what happens is when this PC1 is going to send a traffic, so he will say 192.1 is my source, and let's say the destination is 8.8 for an example. Okay, source port is something around 5267 like that, and destination port is 53. Okay, so let's assume this is the DNS traffic kind of a thing. Okay, now when this packet reaches the FortiGate firewall will do what? It will modify the source IP. So it will change your 192.1 to 1.2.3.4 and destination will remain as 8.8. Source port will also remain as 5678. It is not changing the source port. Okay, only the IP is being translated. Clear? And when it does that, your firewall will maintain a NAT table, right? Where he will say that, hey, when I got the traffic for 192.1 with the source port 5678, so I have modified it to 1.2.3.4 with the source port 5678. Clear? You can clearly see that only the IPs is being modified. Your ports are not. Okay? Clear? Makes sense what I'm saying?
Yes.
Okay. Now, what happens is this packet is now being sent to the internet. Let's say on the internet, there was the Google DNS. Okay, Google DNS, where the traffic was meant to be sent. That was with the IP 8.8.8.8. So the traffic reached in here. Now what will happen? The DNS will try to respond to you, right? So he framed the response. Okay. So when he is replying, what is the reply that he's going to send is? He will say that, hey, the source IP now is 8.8.8, destination is 1.2.3.4, just the reverse, right? Source port is 53, destination port is 5678. Clear? Clear? This is the reply back which will be sent towards the FortiGate firewall. When the FortiGate firewall receives that, the FortiGate firewall will easily know that, okay, hey, I have to do the reverse NAT. It knows that based upon the destination 1234 on the port 5678. So this has to be translated back to 192, right? Correct? Reverse NAT will happen. right? So what it changed, it will revert it back, right now. So the packet which will be sent further will look like this. Let me draw it here. It will look like response is coming from A.8 only, but now this has been changed 192.1, right? 53 and 5, 6, 8, 5, 6, 7, 8, whatever the port was, right? And then the packet will reach to the PC1. Make sense? Clear? Now, the same thing happens with the PC2. So your PC2 is also trying to generate the traffic. He is also saying that, hey, my source is 192.2 and I am sending the traffic to A.8.8. I am using the source port as, let's say he came up with something different like 7890, something like that. Destination port is 53. Makes sense? This packet is reaching the FortiGate firewall. What the FortiGate firewall will do? FortiGate firewall will modify this. FortiGate firewall will say, hey, the source is modified now to 1234 and destination is A.8.8. Source port is 7890. Destination port is 53. This packet has been sent towards DNS. Now, your DNS will try to do what? It will try to respond to that. So he's sending a reply packet. Now, and of course, when the netting was done, so a new entry will be created, right? He will create that 192.2 with the source port 7890. It has been modified to 12347890. Clear? Okay. Now see what happens is when there's a reply will look like this. A.8 is sending traffic back to 1.2.3.4, right? Source port is 53 here. Destination port will go as 7890, right? Now this packet will reach to the FortiGate. FortiGate will do the reverse NAT, right? He will translate back, yes or no? Reverse NAT. So when he will do that, the reply packet that will be sent further will look like this. That the reply is coming from A.8 and destination is 192.2. Source port is 53, destination port is 7890. Clear? And this is the reply packet that is received to the PC2. Make sense? Okay. So there is no issue, right? See, both the PCs are trying to reach to the same destination. And every PC, every source is getting translated to the same IP. Yes or no? They both got NATed to the same IP 1234. Yes. But still, when the response was coming, the firewall was not confused. He exactly knew that this reply packet that he is getting is for PC1 or PC2. How? Based upon the uniqueness of source port, right? Because source port was not same. Clear? Now, what if the source port is same? And that is a possibility, okay? You cannot rule that out. If you have a very large network, that means you may have 10 of thousands of PCs, machines connected in your LAN network. That is a possibility, right? And every machine is behaving as in own, right? So whatever my Chrome will use, there's a possibility that your browser may also come up with the same random port, right? Yes or no? That is a possibility because you also have to choose from these many range only, right? My machine also have to choose from these many range only, right? Correct? So for the same destination, there is a possibility that two different machines or two different sources can use or can send the traffic with the same source port. If that happens, then that's a challenge. What is the challenge? See, with reference to your PC1, the PC1 flow is in that way. But with reference to PC2, for the same destination, okay, what happened is, luckily, this PC2 also came up with the same source port. That was 5678. Clear? Now this packet is going to FortiGate. FortiGate is going to translate it, right? So FortiGate did what is, FortiGate said that, okay, fine, I have got a packet. That packet is with reference to the source 192.2 and source port is 5678. So now when he's going to translate it to 1234 and the source port is 5678. Now this is a conflict, yes or no? How this is a conflict? If someone is not getting that point, that why I'm saying it's a conflict, let me show you how it will create a conflict. Let's say this translation happened, then the packet which has been sent out will look like this, 5678 only with the port. Now when the reply traffic will be there, okay, reply traffic will also carry 5678 as a destination. So when this reply packet is received on the FortiGate firewall, see the destination and the ports here. See it. It is 1, 2, 3, 4, and 5, 6, 7, 8. So when the reply traffic is there, the firewall has to revert back the change, right? So when he will go back to his netting table, what he will see? That I have two entries for same thing. So he cannot take a call that whether this reply packet is for PC1 or PC2 because this is same, right? Makes sense what I'm saying? Clear? So this is why I said that in the starting itself, it will create a conflict onto that part. Okay. Now, when that happens, the firewall will immediately identify that. He will say that, no, I have a similar entry into my netting table. So then what he will do is he will perform the patting, that is source pat. So he will automatically change the source port to some random port which is not in his table, okay, to make it unique. So it will come like this. Let's say he says that it is 7890 here in this case. Now this is unique, right? So when he will send the packet, he will say that 7890 here. If a similar kind of an entry is being created for the same destination, then it will create a conflict, right? That's why I use the statement in the starting that source pat is done automatically by the device. Okay, that's the condition. Okay, we do not do any configuration for that. Okay, clear? Here what happened is both the PCs are sending the traffic to the same destination with the same source port, right? That is when the patting translation will happen. Okay, if they are having different source port, then that's not a concern, right? Clear? So now see the IP is also translated as well as the ports is also translated. Now if the response will be formed, that will be found with 7890. Now this is unique, right? So if this reply is received on the FortiGate firewall, the FortiGate firewall can easily know that, okay, I have to revert back these to this and that, right? So hence it will again be sending it back to 5678 and then he will receive it. Fine. Okay, clear? That's called overload. So in short, what I'm saying is overload supports pat. Okay, so the patting is supported here. Your overload supports pat. Okay, now one more time. Okay, first understand this. Okay, when we say that I see you when there is a packet, okay, you have four things: source IP, destination IP, right? Source port and destination port. Clear? Okay. So
Yes,
in
sir.
terms of NAT, you can either modify the source IP or the source port. Similarly, you can either modify the destination IP or the destination port. Clear? NAT means what? Translation. Clear? When you translate the ports, okay, when the ports are translated, that is called pat. Okay, when you only are dealing with the ports, that is called pat because port address translation. Make sense? Is it clear? The terms are clear? Okay, now say this. So if I say that I have configured a source NAT, that means I am saying that I have configured in order to translate what? Source IP or source port. Clear? That means patting can also happen in that case. Clear? Source patting. Okay.
Yes, sir.
But if you have configured DNAT, that means you want to modify either the destination IP or maybe the destination port. Clear?
Yes,
Clear.
sir.
Okay. Now, this is what so I said that we do not do any configuration. Okay. We will not do any configuration to handle source port translation. Okay. No config is needed. Clear? This is performed automatically by device. The firewall will do it or any router will do it. Okay. We do not do any configuration which will point out to translate the source port. We only do the configuration for source IP translation. Clear? But for destination IP and destination port, we have the control. So we will be doing the configuration as how the destination IP or the destination port will be translated. Clear? Okay. Now saying that, coming to this point. So what I said is that there are 4 types of source NAT. Okay. First type is overload, second is one-to-one, third is fixed port, and fourth is port block allocation. Now, overload means many to one. That means if there are multiple sources, as in this example, PC1 and PC2, you have 2 PCs. So both the PCs are getting translated to the same IP 1234 1234. Clear? Why we call it as many to one. Clear? You might have seen in your company, you have a single public IP, but all your users are able to reach the internet, right? How? Because all the users are getting NATed to the same public IP. That is many to one. Clear? Your many to one source NAT supports patting. That means if in case there is a situation where 2 NATs has been performed, which may create conflict, which I was just explaining you. In that case, the firewall will automatically perform the source pat. Okay, that's why I said that the overload supports pat. I'm saying overload supports pat. Okay, see, it is actually an IP to destination pair. When the NATing table is maintained, now see, NATing table is maintained like this, that I have gotten traffic from 192.1 with the source port 526 or 5278. Okay. For destination as 8.8. Okay. So see, this is what you have here, source IP. This is your source port. This is your destination IP. And this is your destination port. Clear? Clear? So this will be NATed. Okay. When this will NAT? See, when it will NAT now, what happens is, it will say that the NATed source IP now is 1.2.3.4 with the source port 5678, destination IP 8.8.8, destination port 53. Make sense? Now, let's say 192.2 is also coming with the same source port. Okay. But here the destination is different. Let's say the destination is 1.1. Okay. Destination port is 53 only. So what happened here is destination IP is different. Okay. So now when the NATing will happen, the NATing will happen as that 1.2.3.4, right? And source port is 5678 only. And destination is 1.1 with the port 53. Now, please note here, you cannot say that it is causing the conflict. Why? Because when there will be a reply packet, that reply packet will contain the source IP and destination, right? So based upon that pair, the firewall can easily identify that yes, the reply is for which one. Correct? Okay. But if the similar thing happens, let's say he is coming with the 5678 to the 8.853 destination only. If this happens, then that's the concern, right? Because now it's not possible for the firewall to identify that, right? See it? So now when it will modify to 5678 towards destination 8.8 port 53, now this entry and this entry, these are conflict. Got it point? Is this clear first thing? Now coming to the question which you asked, what if my source port and destination port is same? Okay, in that case, my question is that if it is same, is the destination also same? Okay, fine. If that's the case, let's say for example, let's take an example of port 500, likely, okay, VPN traffic. Okay, so that is trying to go to some destination which is 172.1. Destination port is also 500. Clear? Clear? Assume you have applied the source NAT. So what will happen is 192.1 will be modified to 1234. Source port will be 500 only. Destination IP is 172.1. Destination port 500. Clear? Now let's say there is another traffic 192.2 with the port 500. He's also trying to form the VPN with 172.500. Clear? Now here what will happen when the source NAT will happen? The same logic. 1.2.3.4, but he cannot create it for 500 because if he create that and for destination 172.1 500, now this is conflict, right? So what will happen? This is not going to be the case. In that case, it will translate the source port. So it may use any other random port, okay? Whatever, let's say it uses 6780 and destination as 172.1 port 500. Clear? The point that I'm trying to make is something should be unique. Either the source IP, source port, destination IP, or destination port. Something should be unique so that the firewall can easily identify that the reply which I am getting has to be sent back to whom. Okay, clear? Now the next type is one-to-one. See, one-to-one says what? One-to-one type of NATs says that if you're dealing with the one-to-one setup of the source NAT, he says you will get two options. Okay, you will get two options. One is to enter the external IP range and one is to enter the internal IP range. External IP means NAT IP. Okay, so let's say for an example, I have defined a range saying that 172.1 till 172.5. Let's say I have defined this range. And internal IP range, that means your client IP, okay, or your machine IP. That means the internal IP. Let's say I'm calling it as 192.1 till 192.5. Now what happens here is first come, first basis. First come, first basis. That means, for example, the first traffic that came was from 192.5. So 192.5 will be translated to 172.1. Clear? He will get the first IP. So he will be modified or translated to 172.1. Let's say the second traffic that is coming from the PC with the source 192.3. So he will be getting 172.2, the next IP. Let's say the next PC comes as 192.2. He will get 172.3 IP. Okay. Let's say the next PC that is coming is 192.4. Now he will be translated to 172.4. Let's say the next is coming as 192.1. Now he will be translated to 172.5. Make sense what I'm saying? So whosoever comes first, he will be getting NATed to the first IP that is available in your IP pool. Now, if there is a sixth packet, let's say that there is a sixth machine who is coming 192.6. Now his traffic will be dropped. Why? Because the firewall will say that as per the NAT pool, I do not have any IP left. I have allocated all the IPs to the respective sources. That's called one-to-one. So saying that, it means that every time now when the 192.5 machine will send the traffic, that 192.5 will always be NATed to 172.1. Clear? Here, you do not have control that who will get what. You do not have control onto that part. Okay, because anyone who comes first, he will get the first IP, and hence for the it's like likewise. Clear? Please note, in one-to-one, the PATs is not supported. Patting is not supported. Clear? PAT, it do not work. No source port translation. It can only help you to translate IP to IP. Clear? Okay. Now, if I talk about the third, that is fixed port. Right? If I talk about the fixed port allocation, now see this, the third type, fixed port. Here also, you will get similar kind of an thing, okay? You will get the similar kind of an option. Okay. So let's say here in the fixed port also, you define the same thing. But this time you are using the type as fixed port. Okay. Now in the fixed port, what happens is, let's say the first traffic that is coming is from 192.5. Now 192.5 source will be NATed to 172.5. Okay. That means fixed. So it is like if the next packet is coming as 192.1, we will get NATed to 172.1. Okay. Likewise, 192.2 will be NATed to 172.2. 192.4 will be NATed to 172.4. 192.3 will be NATed to 172.3. Clear? See the difference here? Here in the fixed port, you have the control. You exactly know that my source 192.1 will always be NATed to 172.1. 192.2 will be always be NATed to 172.2, and likewise. It's fixed. Okay. Whereas in one-to-one, everyone was getting a single IP. In the matter of the sequence, how I am getting the traffic, right? But here that's not the case. No matter what is the sequence that I get the traffic from which source, always that source will be NATed to that respective NATed IP as per your defined range. Clear? Please note, your fixed port supports PAT. So if in case such a conflict happens, which we have discussed previously, if that happens, then it is supported here. So he can do the source port translation automatically to avoid any such condition. Clear?